Hey guys, today we're talking about solving one-step equations. An equation is a sentence stating that two quantities are equal. So in the past, we've had expressions like this one, x plus 3. That's just an expression where the variable could be any number. But with equations, the value of the variable has to make the equation true. So it's called the solution. So x plus 3 equals 5 has a fixed number that has to be x because we know that 2 plus 3 equals 5, then 2 is a solution to the equation. So the way that we solve these is we make sure that we always keep things equal by using inverses. For example, I like to think of this equal sign as being a balance. Everything on the one side has to equal everything on the other. And so whatever we do to one side, we have to do to the other. So if I add 3 to this side and get 13, the only way to keep them equal would be to add 3 on this side to get 13. And then to undo that, I could take 3 away from both sides and be back at 10. So these are called inverses. Adding 3 and subtracting 3 are inverses from each other. They're opposites. So to get rid of something, we always do the opposite. So let's explore that further. First thing that I do for each equation is I write it down. So in your notebook or on your piece of paper, you should have example 1, x plus 6 equals 4. Draw your streets because we are going to keep these balanced. I like to think of them as streets because it looks like, something that cars would go this way and this way on. Now we ask ourselves, if I want to get x isolated by himself, okay, he needs to be isolated. I only want x left on this side. How do I get rid of a plus 6? I subtract 6. And I apologize, that was supposed to be a 14, not a 4. So taking 6 away from 14 leaves me with 8 on this side, and taking a positive 6 and taking 6 away from it leaves me with just the x, because these are inverses, so they cancel each other out essentially. So x equals 8. We can check our work by plugging it in our calculator. Take 8 and rewrite our equation, but after you do that, plug in 8 for x. And you get 14, so we know that it works. Over here, we're going to draw our streets again. Okay, so we have 15 equaling b plus 8. And I want to get the b by itself. So how do I get rid of a plus 8? I take 8 away from both sides. And when I do so, I'm left with b on this side equals, and 15 minus 8 gives me 7. Okay, so what if I accidentally thought that it was 6? Well, when I rewrite and I check my work, I plug 6 in, and I know that 8 plus 6 gives me 14. So I know that I did something wrong. Only then could I go back and figure out, oh, b actually equals 7. I must have done my subtraction incorrectly. So 7 plus 8 equals 15. Do you see why it's important to check your work? Okay, and a lot of times we rewrite this b equals 7. Okay, so x equaled 8 and b equaled 7. Now let's try graphing these. We know x equaled 8 and b equaled 7. So I put a dot at 8 and I mark it x. I put a dot at 7 and I mark it b. Notice that it's a solid dot saying, hey, here's 7 and here's 8. Let's try one more together, and then you're going to try a couple on your own. Y minus 6 equals 9. Draw your street first. And how do I undo a minus 6? Well, I add 6 to both sides. So y equals 15. I could plug that back in and say 15 minus 6 equals 9. I don't have to write it out every time. And then if I wanted to graph this, I would start, I like to do 15 in the middle and then just one number on both sides is sufficient. and I plot my point at 15. Okay, so try 4 and 5 for me, and I'll be back in just a second to show you what I did. Okay, grab your red pen. First thing that we need to do is take 3 away from both sides to get rid of that plus 3 after I draw my street, of course. And I get x equaling, and 23 take away 3 is 20. 20 plus 3 gives me 23, so I know I did it right. And then to graph it, I know it's at 20, so I make a solid dot. Okay, over here I'm going to add 4 to both sides. So A is equal to 47 because 47 minus 4 gives me 43. So when I graph that, 47 in the middle, 48, 46, and a solid dot at 47. Okay, so now let's look at a problem where we have to write the equation ourselves. You have 50 cupcakes in your kitchen. The total number of cupcakes and brownies in your kitchen is 165. Write an equation that can be used to find x, the number of brownies in your kitchen. So we know we have 50 cupcakes, and we know we have some brownies, which we're calling x. And we know that together those is 165, or they are equal to 165, right? So they want us to write the equation, which we did. Now we can solve. Take the 50 cupcakes away from the 165 desserts that we have, and we get x equaling 115. If you want to draw your streets, because it helps you keep them balanced, you can. So we know that there's 115 brownies. So let's look more at what we do when we have a minus. So in this case, x minus 2 equals 1. Draw your streets, and how do we get rid of that minus 2? We add 2 to both sides. When we do that, we get x equaling 3. Okay, and when we go back and we check our work, 3 minus 2 gives me 1, so I know I did it right. Over here, draw your streets. So how do I get the minus 4 away from r? I add 4 to both sides, and I'm left with r equaling 12, which can be written like so. And if I plug it back in, 12 minus 4 gives me 8. Okay, so you try these, and I'll be back in just a second to show you what I did. All right, the first thing that I did was draw my streets, okay, because I like to make sure that I'm keeping things balanced. So if I have a minus 3, I'm going to add 3 to both sides, and I get y equaling 7, because 7 minus 3 equals 4. On this one, I'm going to add 8 to both sides, and x equals 17, which can be rewritten like so. So make sure you check your work with a red pen. Okay, so now let's look at another word problem. A pair of shoes costs $25. This is 14 less than the cost of the pair of jeans. Find the cost of the jeans. So we know the shoes cost $25. And we know that this number is the jeans, but 14 less than the jeans. So the jeans minus 14 gives me 25. So now draw your streets and make sure that you are doing the inverse of a minus 14, which is a plus 14, to both sides. So we're left with the jeans equaling $39. So jeans equal $39. And remember, when they ask you a question or they tell you to find the cost, it's helpful to write it out. The cost of the jeans is $39. And that's all I have for you today, and I will see you next time.